Today's session, we're going to talk about Pivotal Cloud Cache. It's a new minted service on Pivotal Cloud Foundry that is available to you where you can actually use this service to do a little bit of caching in your microservices. Everybody needs that. I am Pulkit Chandra. I am the product manager for Pivotal Cloud Cache. And OK, something that legal asked me to do. So, why do I need a cache? A lot of you already are very familiar with microservices patterns. Most of the time, it's a general recommendation that you keep your states external to your service. And there are multiple Cloud Foundry services which are available on a marketplace where you can actually store your data. Now, this becomes specifically critical if you have the nature of the data is pretty much hot data, which is fast transactions. You just quickly need to store your data. It's a key value store, and you need to retrieve it based on your key. The key thing is for you to keep focusing on the application that you're developing. Whatever other services that you're doing or using needs to be easy to provision, and it needs to be self-managed as much as it can be, and needs to be distributed so that you can actually horizontally scale depending on what kind of load you get that on your application. So you can actually scale your application depending on the load on the application. You can actually scale the service. So that's what we call cloud-native data that actually understands that in the cloud architecture, scale is a variable. It changes. And you're going to hear me keep saying scale and again. So what's the problem? Bring your database, put it as a service. It's all good, right? Not quite. We tried it. We failed. Scale. It doesn't work. If it extends to a certain point, you can't just bring all your databases or your caching products and you start scaling. And the problem is that when you look at this huge number of applications which are talking to your services, the management becomes a huge burden. The workflows becomes extremely complicated. And that's a problem. Bringing your old products simply to Cloud Foundry or cloud applications is not going to cut it. This is a picture I took like 3 weeks ago I'm from India, from Delhi. This is a metro station at 12 p.m. on a Wednesday, and it's still filled. I couldn't really get the photograph at 6 p.m. because it was difficult to even take my hand out and take a picture with my phone. It was so crowded, and love this picture. So the problem is all these solutions work great in other countries, but have challenges to be successful in India. Scale is the biggest problem. When you expand your solution to whatever solution that you have, transportation or anything, it doesn't work well with 1.2 billion people, apparently. And cloud applications have kind of the same problem. So what do we do? Well, cloud scale is what we call your applications are hitting. And they need some kind of similar solution on the services side, on the states, or basically on the services which are managing the state for your applications. Basically, industrialization is the solution that you're looking for. You want to industrialize the service that you have on Cloud Foundry so that it can actually handle the cloud scale. What that took us was the thinking about Pivotal Cloud Cache. Now, in a typical service that you create outside of Bosch or Cloud Foundry, what you're going to do is you're going to create a bunch of startup scripts. You're going to have some kind of use case in mind, according to which you will set up some properties around that service. You're going to configure the cluster because you have a use case, you have a startup script. Now I'm going to configure the cluster, whatever that make up for. Then you're going to run. And then you're going to wait for feedback so that you can do the cycle all over again. Because you're constantly improving based on how your application is behaving, how your users are changing their behavior, how application is adapting, and your service needs to adapt. This is great. But these two things maybe require some attention. These are the two things that maybe we can automate partially. So that was our thought. Here comes Pivotal Cloud Foundry that actually takes your applications and easily deploys that on the cloud. It actually has the similar kind of concept built into it that things which are not really relevant to your business or your application, you want to automate that using Pivotal Cloud Foundry. Now, Cloud Foundry has a concept of a plan for your services. So we said, what if we looked at a plan as a use case? Broadly speaking, it doesn't have to be very specific. But what if this is the blueprint that I can take my service and actually deploy using this blueprint? It makes few things at least less, or the number of choices that I have to make as a developer a little less. Might help. So we said, OK, now how does this world look like? You have a use case in your mind. You actually configure the cluster. But it's kind of configured because you chose a plan which had a list of recommendations or a kind of things that you feel are obvious to these use cases and are always true, independent of what the load is. So you have that already configured, and you put some more configuration on top of it, which is very specific to your application. You run it, you get the feedback. Great. You do that again and again and again. That's what Cloud Foundry is all about. And that's what our thought also went in when we actually looked at the service. Now, what does it actually look like? So you go to CF CLI. You say CF create service, P cloud cache. The plan is cache. It's just a cache. What it does, it actually generates or spins up a bunch of VMs using BOSH on the IaaS of your choice. Now, this is a little different from previous incarnations of these services, where all these VMs were always already there, and you used to patch them every time you say CF create service. Now it actually spins up a VM, patches that VM, applies a list of kernel parameters that we feel are necessary for this caching plan. It actually applies a list of JVM properties, which we feel are necessary for this plan. And under the hood, it's using Pivotal Gemfire, which is backed by Apache Geode, open source. And it's a Java-based product. So we have a list of JVM properties that go along with it. Now, there are other things that you might want to do. For example, if your application has more load now, and you want to increase the capacity of your service because of that. So you can actually say CF update service and increase the number to 5. So it's going to go and look at the cluster. It already has 4 server nodes. It's going to actually spin up an additional server. Now, what's a little catch here is that number of servers says 5, but when you actually see 7 cylinders there. 3 of them is what we call as locators in a Gemfire system or Apache Geode system. These locators are not VMs that hold the data. They are responsible for communication and a little bit of management of the cluster. So they always remain at the same level. We haven't hit a load in which we have to increase that, but we are always listening. Let me know if your load actually makes you believe that we need more locators. It's not just number of servers. I haven't shown more things here, but there are other properties that we keep on adding. It's things like if you want to, let's suppose you have a code that you actually want to run close to the data, which means that you want to push your code onto this Pivotal Cloud Cache service and run with next to the data, that means you have now some custom Java code which is going on, generating a bunch of variables, using the Java resources that might just generate what in Java we call garbage, right? So that means you might want to tune your new size because you have a bunch of short-lived objects. So again, you can tune the new size within certain parameters, and we have decided those parameters based on some of the safeguards that we have placed on the service so that you never topple over or overcommit your memories from JVM point of view. So the new sizes that you can actually tune is within a certain percentage of the total JVM heap size. So we published that in our documentation, how to choose and how about going to do this. Now, I'm going to talk about some of the common design patterns which come along with this particular service. These are well-known patterns in general when it comes to caching, but we just want to put it out there that we actually support these things out of the box. One of the favorite and most easy to do is an application look-aside cache pattern. You have two instances of a microservice that in a space, you spin up your PCC cluster. Before that, you have a database already. So let's suppose that you're talking to a database directly. Now you want to introduce the concept of a cache in the middle so that you can actually increase the responsiveness of your application, for example. So you say CF create service, it's going to spin up a PCC cluster for you and bind this particular set of microservice instances to PCC cluster. And if there is a cache miss, your application actually goes to the database and loads that data and pushes that data back to the cache. So it's the responsibility of the application to manage the consistency between the database and a cache, hence the look-aside cache pattern. So cache misses are expensive, but otherwise it's a pretty performant pattern, a lot of time pretty useful for a lot of folks, but does have its pros and cons. Obviously, when application is managing the state or managing consistency between a database and a cache, it is subjected to certain kind of delays, or there can be inconsistencies, or basically there are windows in this timeline where the system is not exactly in the same state. And consistency is important to us. In fact, most of our plans that we give out of the box are defaulted to be consistent as much as they can be. Another one which is common is session state caching or HTTP session state caching. So you have a lot of your users, you have a couple of TC server or web server instances which are running in a space. A lot of different users start their sessions. All these sessions are going to end up in a PCC cluster. Now, by externalizing all this session data, it's really easy to scale my web services now and handle a lot of this HTTP load that I might have. All my JSession ID is stored. Let's suppose for some reason the user actually loses their session and they restart that session. You can always serve it back. Sorry. Oops. OK, yeah, you can always serve it back using PCC cluster. Front-ending a database. This is a kind of a better form, so as to speak, from look-aside cache pattern, because consistency is much higher here between a cache and a database. So you have a couple of instances of microservice which are in a space. They are reading it directly from your database. In this particular pattern, your focus is that PCC cluster is always the gateway through which you're going to reach to your database. That means if there is any kind of cache miss, you're going to rely on PCC cluster to actually reach out to the database and fill that back into the cache and then feed it back to the application. So The reason that it's a little better is because the management or synchronization responsibility between a database and a cache is handled by PCC rather than the application. It does mean that you have to train the PCC cluster, or so as to speak, configure the PCC cluster in a way that it can talk to the backing database. All right, my favorite. So what if that you want to take data between two different PCF foundations or within the PCF foundations? So replicating data is a challenge. In fact, I don't believe that any of our data services right now are handling this. So this is something that PCC handles pretty well, thanks to Gemfire. So there are a couple of instances of microservices talking to a PCC cluster, same pattern. There are a bunch of reads and writes which are going on. And then you have another microservice and another PCC cluster. Since all these clusters are dedicated to each space, there is data flow between them, which can be configured in a pretty easy few step. This is right now not available in PCC, but coming up in the next version pretty soon in December. And not just between a single foundation, you can actually do that across foundations. Now, this actually enables you to first time have multiple applications see the same view of the data across the data center, across geographies in PCF Foundation. So this is the very first time it's happening. We're very excited for that. It's coming in December. Now, the unique thing about this particular implementation is it actually takes care of a lot of performance characteristics. So I'm going to dive down into performance by showcasing a Netflix's benchmarking tool, which is open sourced. And our team did a pull request for Apache Geode. So you can actually push that. It's nothing but a Java application. Just CF push this in PCF Foundation, bind it to any of the services that NDBench actually supports, and go to the UI and just press start. It actually showcases a lot of performance numbers. So this is what NDBench actually looks like. You can tweak a lot of properties around how you want to run your performance test case. It's all available, open sourced on GitHub. Right now, I've got 16 threads for read and write going on with a single PCC cluster spun up on a GCP environment. Nothing special about this cluster. Literally just went in to GCP, registered myself, installed the tile, and spun up a cluster. I haven't done any kind of tuning, anything at all. And I'm getting an out-of-the-box numbers. Let's see what's happening right now. Ooh. So it actually displays things in microseconds, and I have 95th percentile selected, and I'm seeing something around 11.8 millisecond performance of an absolutely nothing tuned, no special networking available cluster. Like, this is simply, and I can say for sure that if you move to vSphere or some of the VMs that actually have high performance networking, you would see a lot better than this. Okay. So one of the key things to achieving that kind of performance out of the box was to ensure that there are certain defaults that we have selected for the Linux kernel that we have. Gemfire, which is the system that we use in PCC, can be resource intensive depending on how much load it has, the application is putting on it. And to ensure that it's successful, there are a bunch of tunings that can be done on the kernel, so we just do that out of the box. Yeah, questions? Yeah. Yeah, so the question is, how do you secure the cache in terms of public access? So there is a out-of-the-box security module that we have. The whole cluster actually sits in a service network inside your PCF foundation. And the access is given to you by the virtue of vcap services environment variable or service keys. And we generate random username passwords every time somebody says CF create service. So it's unique inside a particular space. So in general, what the patterns that I've seen is if the service network under which the cluster is actually spun up, that service network has limited access or no access to the outside world, and only PCF applications can access them.
But even PCF, say a certain application types to have access to cache, not any other application in the same PC.
Yes, so if you deploy your applications to the space under which you created this cluster, only those applications have access. So the space developer, let's suppose you logged in with the space developer credentials, you can only create a cluster for your space and only your application talk to that cluster. There are no other applications that can even access or see that it exists. Yeah?
What's the difference between ND bench and the Pulse console?
OK, yeah, I didn't showcase Pulse console because of lack of time. Pulse is a management and kind of monitoring lightweight tool that we have in Gemfire that actually showcases you at a very high level where the cluster is, how many nodes it has, what is the read-write latency, and things like, not latency, but speed. NDBench is an open source tool developed by Netflix. We have done a PR on them to ensure it is compatible with open source Cloud Foundry and Apache Geode to ensure the performance, and it's a performance testing tool, and Pulse is not. So NDBench gives you this one single view, just like YCSB also has an Apache Geode plugin that you can actually run against PCC and see the same code generate performance numbers for PCC or any other tool for that matter. So you have a very consistent and a non-biased performance numbers, which is as easy as CF push application and just start. Yeah. So the question is the WAN replication asynchronous? That is correct. Replicating data outside of a data center or PCF foundation tends to be slow, depending on your network speed. The cost that PCC or Gemfire has to actually replicate this data is extremely low. It's mostly dependent on your network speed. So we have kept it always asynchronous. We haven't found any reason to make it synchronous till now, but we are always open to use cases. Yeah.
What's the consistency model for that WAN replication?
So the WAN replication bit, what happens is that within a cluster, the consistency is maintained down to the time when you have, for example, if you have a hash map, which is an equivalent of a region, what we call as a region in Gemfire, if you have persistence on, it actually goes down. The write goes down all the way to that, and that's synchronous. But the replication happens asynchronous. So you can always ensure that if a single cluster has said that the write is done, the cluster has a copy of that write down to some kind of file system. And the WAN replication is not just, it's working on a TCP IP layer, but it actually has an acknowledgement-based system as well to ensure that it successfully reaches the other side, and only then it removes it from the queue. Yeah. The question is, how do you clear the cache? I'll get to you next. How do you clear the cache? There is a simple API. You can actually use Spring Data Gemfire, which is a Spring Data project. We're 100% compatible with that. There is no change on that. So you can actually say, region.remove, which is the analogous of a hash map in Gemfire. Or you can actually destroy the whole region itself. You can. You can do that. It's a time to live. You can do those settings. Yep.
I was just wondering if there are any plans on the roadmap for PCF to use PCC to any type of federation between foundations to manage synchronization of like spaces.
So the question is, are there any plans in the future for PCF to use PCC to do synchronization between foundations? It's too early to tell. We have been having conversations with our PCF peers about that prospect. I don't know whether that will happen or not, but that is a potential angle that we can actually look at to replicate data. Yeah.
How do you modify a cache, and the modification is deployment or is it just runtime?
The question is, how do you modify the cache? It's a runtime thing. It doesn't change anything. There is a CLI. You can use the CLI, or you can use your code as a configuration. Spring Data Gemfire 2.0 actually introduces that concept. And you can restage your application after you change. Or you can use gfish, which is Gemfire CLI, to talk to PCC cluster and configure the cluster at runtime.
Does it have a UI or some sort which you can see as context?
So Pulse is a way where you can actually run OQL queries, where you can actually see the data as well. There is a UI. Sorry?
Do we have to use a different service for it?
So the question is, do I have to use a different service for it? No, it's integrated. Yes.
If you overflow the region on disk, what's happening because you're on the cloud? So is the VM volatile or is it split?
So the question is, what if the data is overflown from the region onto the disk? What happens? So that's where BOSH is great. So what happens is that if the VM fails, yes, the data actually gets lost, which is in memory. But when BOSH recreates the VM, because BOSH is always watching the process, and it's also watching the VM, anything fails, it recreates it, and it reattaches the persistent disk where all this data is. So as soon as it reattaches, we actually reload the data. So you get the data back. Yeah?
How does this compare to Redis or PCF, and what is the direction, I guess, from Pivotal regarding Redis versus Locators?
The question is, how does it compare with Redis for PCF, and what's the comparison between them? So
The direction, I guess.
oh, sure. So what's the direction, the product direction for it? So Redis for PCF is a single VM plan, handles a lot of cache. Also, Redis fundamentally is a little different system. It doesn't really, it's an AP system, where PCC is a CP system, or it has been configured to be a CP system. It always favors consistency right now. And Redis for PCF right now, because it's a single VM system, it's not HA. PCC, on the other hand, on a single foundation, is always looking at availability zones to shard the data, and it always keeps the data balanced. So even if you lose the VM, it's going to balance the data to ensure the data is equally divided. If the VM comes back, it will again ensure that the data is balanced. So that balancing, basically it's a clustered service, right? So it behaves like that. And Redis for PCF is not a clustered service. And also WAN replication, which is a whole different topic, which also doesn't exist. Sorry? Can you elaborate on multi-gate and multi-port? I don't quite understand this. Multiple cache hash maps or regions? So you can definitely talk to multiple regions from a single client, and you can do manipulation on that. Sorry?
My understanding of the question is, can I query 100 keys at a time or 1,000, and can I put 100 keys at a time?
Yeah, you can definitely do that. It's a put all, get all functions. Yeah.
So how is the cache managed when we have loop
When we have?
redeployment?
So in a WAN replication world, what we are pushing for is an active-active system. So the management of the cache or the cluster is done through CFCLI from a developer point of view. And obviously, platform operators have BOSH management tools to actually manage them. The monitoring capabilities are also integrated, so all the aspects about the cluster is pushed on the logregator, so you can actually attach your favorite tool for Prometheus, Datadog, or whatever. It actually showcases you what's the state, what's going on. Yes?
In your diagram, you had 5 cluster nodes, 3 locators. Is that what that was?
Yeah, so basically, you're talking about the diagram that I showed about the cluster where it has like 5 nodes and 3 plus 3. So that was the locators, which are like 3, which is always stable, which they just manage the cluster. They are VMs that are looking after when a VM loses, how do I ensure the data goes, when a client accesses where it actually is, so things like that. So that management is done by those locators, and they don't hold any data. So they can actually go, come back, doesn't matter.
Has there been any discussion on using some of the PCF functionalities or remove the need for such redundant locators?
There hasn't been. The locators do a lot of things beyond that. So we haven't really explored that, but we're always interested in hearing what's the use case that actually drives you to believe that locators can be managed by PCF. But yeah, we're hearing. Yes, please.
What type of clients that are supporting, let's say like Geode, you've got native clients and also a custom interface.
Yep.
ECC was the client.
So currently, we only support Java clients and Spring Data Gemfire. In the future, we are looking at REST API support to actually open it up for any kind of client that you have. And down the road, we will obviously keep an eye on Gemfire's roadmap to see what can be done for native client support and things like that. All right, in the interest of time, thank you so much.